So in this video, we're going to go over the geometry quiz from sections 4.1 and 4.3. So first of all, I'm going to check and make sure that everything that's written is in my drawing, and it looks like it is. And then we're going to start talking about what we know. We know that opposite sides are congruent, so I'm going to go ahead and put tick mark here and here. So I know that this is 7 meters. I know the opposite sides here are also congruent, so I know that this is 5 meters. Then I know that diagonals bisect each other, so that means that BE here is congruent with ED here, so that's also 4 meters here. I also know that EC, this one down here, is congruent to EA, so I know that this one is also 3 meters here. So those lengths we know. Now we're going to go on to the angles. So I know that alternate interior angles are congruent, so that means this angle down here is congruent with this one up here. So I can say that this angle up here is 35 degrees, and that this angle down here is congruent to this angle up here. So this is 36 degrees. And we know that those two angles added together are going to give us all of B. So 36 plus 35 is 71 degrees here. And opposite angles are congruent, so this one up here is also 71 degrees. Once again, we have alternate interior angles here, so we know that the 41 is congruent with this one down here, so we can put the 41 here. I'm going to go ahead and put 3 arcs here since we've got 1 and 2 the other place. And we're going to do 4 arcs here and 4 arcs here. So we also know that this one is 68 up here. Now, to find angle A and angle C, we're going to add the 41 to the 68, and that's 109 for all of that, and 109 down here. Then we need to use the triangle sum theorem to find the third angle. So kind of want to show you guys what I'm talking about. I'm talking about this triangle down here. And we have 2 of the angles, 35 and 41. 35 plus 41 is 76. So if those 2 angles add up to be 76, we subtract those from 180. And 180 minus 76 is 104. And this angle opposite it, AED, is also 104 because these are vertical angles. And then we have, we could do the other angle one of 2 ways. We should be able to see that there's a linear pair there. Or we can do, there's actually 3 ways we could do this. We could add the 68 to the 36. That would be 104. And then we would subtract that from 180, which would be the same process as here with this linear pair. That would make it, again, 76 degrees, which means the one over here would be 76. So we could use the linear pair. We could also use the exterior angles theorem, where we add 35 to 41 and it equals that exterior angle 76. So there's a variety of ways we could do that problem. So now we're going to go ahead and fill in our blanks. So DC was 5. BC was 7. AE was 3 because EC was 3. And BD was 4 plus 4, which is 8. Then angle BAC was the part that was at the top. It's 68 degrees. It's the bottom part of that angle A. Angle A was 109. Angle ADE, ADE was the top part of the top right angle. That was 35 degrees. Then angle D was 35 plus 36, that's 71 degrees. Angle BCA was the bottom part of the angle C, which is 41 degrees. Then CED was the right of the center, that's 76 degrees. and then AED was the top of the center where the two diagonals intersect. That was 104. So those are the correct answers for those questions. So now we're on the back, and it says, find the variable that would prove the figure's parallelogram and state why the quadrilaterals are parallelograms. So I know that opposite angles are congruent, so I would do 70 is equal to 2m, divide both sides by 2, so m equals 35. Then I know that consecutive angles, this angle and this angle, are supplementary, or I could do this angle and this angle down here. So 70 plus n equals 180. So we would subtract 70 from both sides, so n is equal to 110. Now, why would this prove that this is a parallelogram? Because both consecutive angles are supplementary. Because this was 70 and this was 110. So when I add 110 to 70, that's 180, and when I add 110 to 70, that's 180. The next one, again, we're solving for x and y here. So the diagonals bisect each other, so we know this is true. So I'm going to set 3x equal to 12, so x is equal to 4. Then I've got x plus y equals 5y. Well, we know that y is 4, so 4 plus y equals 5y. We're going to subtract y from both sides, so that's going to be 4 is equal to 4y. So y is equal to 1. So these are our answers, x equals 4 and y equals 1. And the reason is because the diagonals bisect each other. So number 14 through 16 says, determine whether the figure is a parallelogram and choose why or why not based on a property we learned. So on this one, I noticed that we have one tick mark here, one tick mark there, two tick marks there, two tick marks there. So yes, it's a parallelogram because diagonals bisect each other. Number 15, we only have that one pair of angles is congruent, and that's not enough information. So that's what we're going to write. We would have to have both, either that both pairs of opposite angles are congruent or that one of those angles is supplementary to both of its consecutive angles. In number 16, we see that one pair of sides is both parallel and congruent, and that is enough information. So we would say yes here again, because one pair of sides is both parallel and congruent. Now I'm going to go over the 4, 5, 4, 6 quizzes, and notice you'll be able to tell which version you had by what the measure of angle PTQ is and the measure of QS. So I want to start with the one on the left. What we know first of all is that let's go ahead and talk through these angles. So we're given PTQ. Hold on one second. Let me move this over because it's off my screen. There we go. So PTQ is this angle down here. It says that this is 31. If that angle is 31, then that means this angle right here is 31 because they're alternate interior angles. And remember that all our diagonals in a rectangle are congruent, so that means this angle up here is also 31. So, sorry, it's not writing very clear. So this is 31, and this is 31, and this is 31, and this one right here is 31. So all four of those are 31. And then we also know that this is a rectangle, so these angles are right angles here. So that means that 90 minus 31, that's how I can find that other angle up there. And so that's going to be 59 degrees. So that means that this right here is 59 degrees, and that right there is 59 degrees, which means these down here are 59 and 59. And then we can find that center angle because, again, 59 plus 59 is 118. So this right here has to be 118. 31 plus 31 is 62, which means this has to be 62. Opposite angles, remember, our vertical angles are congruent, so that's the way that would work out right there. So that can give us then STR, which is 59 degrees, QPR, which was 62 degrees, SPR, which was 118. And then when we're talking about RP, we're talking about part of a diagonal, right? So on this one, we were given that QS is 37. Notice here we're given that QS is 37. And so if we're trying to find RP, RP is 37 divided by 2 because that's half of it. So that was 18.5. So this is 18.5. Then QR, we're going to have to set those opposite sides equal to each other. So we know that this side is congruent with this side. So we're going to say x plus 5 equals 3x minus 9. That's 2x. We're going to add 9 to both sides. That's 14. So x is equal to 7. And some of y'all stopped right there and didn't finish. And we got to plug that x back in to get QR. So that's going to be 3 times 7 minus 9. And that was 12. So that makes this length right here 12. And then RS is the other pair of sides. So we've got these other opposite sides here that are congruent. So with that one, we're going to set 7y minus 21 equal to 4y plus 3. So 4y plus 3 equals 7y minus 21. We're going to subtract 4y from 7y. That gives us 3y. We're going to add the 21 to the 3. That's going to give us 24. So y is going to be equal to 8. Then we're going to plug that back in again. And it really doesn't matter which side we plug it back in. So we could do 7 times 8. 7 times 8 minus 21, that's equal to 35. And so that's this other length right here, 35. Now I'm going to do the same thing with this other problem over here, just so you can see it with another set of numbers. So STR this time, first we got to put PTQ up there. So again, hang on a second, I don't know what's going on here. So PTQ, what in the world? Not sure why it's not writing out. Well, let's just go back to red. Maybe it'll work then. Nope, it's having issues. Let me click over here. Maybe then it'll work. So we've got PTQ. You know what? I don't know what's going on. Let's just slide this over a little bit. Maybe that will help me. Okay. So we've got PTQ right here. PTQ there. Hopefully you saw that. Not sure why my pencil is not writing. So for the other version, I just had to make it bigger. It wouldn't not stop doing that. So PTQ is 34. So again, this is an isosceles. These are all the congruent. So this one's 34 here, which means this one's 34 here, and this one's 34 here. So once again, we got right angles up here, right angle there, right angle here, right angle down here, because this is a rectangle. That's the definition of a rectangle. So we are going to subtract 90 minus 34, and that's going to give us 56. So that means this angle here is 56, and this one here is 56. And these down here are 56 and 56. Okay? Then again, when we're trying to find this angle in here, in the center here, we got a triangle down here, notice. So we can do 56 plus 56, that's 112. So this angle over here would be 112 because, again, it's the exterior angle to the one we just did. We could do 34 plus 34, that's 68, and that would be this angle. Remember, there's multiple ways to do this. We could do the triangle sum theorem, we could do the exterior angles theorem, or we can do the linear pairs once we find one of them. So STR is 56, QPR is 68, and SPR is 112. Then we're looking for RP. And again, it gave us that QS was 25. So RP is equal to QS divided by 2. So that's going to be 25 divided by 2, which is 12.5. So this is 12.5. Then we've got QR. Again, opposite sides here are congruent. This side is congruent with this side, so we're going to set 5x minus 3 equal to x plus 5. Subtract x from both sides. That gives us 4x equals 8. Add the 3 to both sides. X equals 2. Got to plug that back into our equation for QR. So that's going to be 5 times 2 minus 3. So that's 7. And then RS are our other pair of opposite sides. So I'm going to set those equal to each other. So I've got 4y plus 8 equals 7y minus 4. Subtract the 4y from the 7y, that gives us 3y. Add the 4 to the 8, that's going to give us 12. So y is equal to 4. Plug that 4 back in. So, and we're looking again for RS. So that's going to be 7 times 4 minus 4. That's 28 minus 4, which is 24. So that's the first set of problems on both versions. Okay, going back to our first version. So this time we got a rhombus, and we're given that BAC, that's BAC was 23 degrees. We're given that DE right here is 5, and we're given that AC is 24. So let's go ahead and say if that's 24, if DC is 24, then AE is equal to 24 divided by 2. So that's going to give me 12 here and 12 here, and this would be 5 and 5 here, which means DB would be 10. So then the other property that we need to remember is when we have the diagonals bisect angles in a rhombus. So if that one's there is 23, then this one right here is 23, and the whole thing would be 46. Then to find angle B over here, we're going to take 180 minus 46. And that's going to give us, what is that, 134? So that's what this angle is, 134, the whole thing. But then to find the parts, we're going to divide that by 2. And 134 divided by 2. This is equal to 67. So that means this angle here is 67, and this is 67. This one's over here is 134, 67, and 67. And these down here are going to be 23 and 23. and 46. Recall that all of these angles in here are right angles as well. So now we have all our pieces of information. So it says AEB. AEB is the angle, is this angle right here, AEB. That's 90 degrees because our diagonals are perpendicular. CBE. CBE is that angle right there, so that's 67 degrees. Then we have DCB. DCB is that whole angle down there, so that's 46 degrees. Then EB would be 5. We've already got that marked. AE, which is half of the 24th, that's going to be 12. And then DB is all of one of those diagonals, and so 5 plus 5 is 10. So we're going to go to the other version now. So now I'm going to go over the other version of this question too. So we have BAC here. BAC is, sorry, I did that wrong, y'all. See, even I have to think. BAC is up there. So this is 13, which means this is 13 again because the diagonals bisect the angles, which means 13 plus 13 is 26. So down here again we have 13 and 13, and the whole angle is 26. Then to find angle B right here, all of it, we're going to do 180 minus 26, and that's going to be 154. So that means this whole angle here is 154, and to find the parts of it, we're going to divide that by 2. And 154 divided by 2 is 77. So that means this part right here is 77, 77, 77, 77, and again 154 over here. All right, let's see some other things that we're given. So we're given that DE is 9. So if that's 9 there, then that's 9. And it tells us that AC is 80. That's the whole diagonal, so we're going to do 80 divided by 2, which is 40 for the parts. So this up here would be 40, and this down here would be 40. And we should know also that all the sides are the same length. So all 4 sides are congruent in this shape. So let's go. AEB is 90. So let me go ahead and see if I can show you where AEB is. AEB is 90. And remember, all of these angles in here are 90. So that was 90. CBE. CBE is all of that. Sorry, I did that wrong again, y'all. I need to go home. I'm tired. Let me do this again. CBE is this part right here, so we're talking about 77 degrees. And then DCB, DCB is all of that down there, so that's our 26. All right, then EB is right here, and we said that was 9. AE was this part right here. We said that was 40. And then DB was that whole length, so that would be 9 plus 9, which is 18. So this is back to our first version, and this is a square. So this is what we know about a square. It's got 4 right angles, and that the diagonals are perpendicular as well. So we know that all 4 of these angles in here are also right angles. When the angles are bisected by the diagonals, we know that 90 divided by 2 is 45, so this is 45, and this is 45, and so on. All of those angles would be the same. So it's asking us for MKN. MKN is this angle right here, so that's 90 degrees. Then it's asking us for LMK. LMK. LMK is right here, so that's our 45. And then MLP, MLP is 90. Then we're going to talk about LN. Ln is our diagonal, and it tells us LK is 1. So if that's 1 and this is 1, then obviously the whole thing, let me make that a 1, y'all. That's 1 and that's 1, so 1 plus 1 is 2, so Ln would be 2. LP now, we know that all 4 of our sides are congruent here because this is a square, and a square is a rhombus. So we should be able to set those opposite sides equal to each other and then solve for x and plug it back in. So 5x plus 0.15 is equal to 4x plus 0.4. So 4x minus 5x is x. And then we're going to subtract 0.15 from 0.40. So that's going to give us 0.25. Then we have to plug that back in for LP. So that would be 4 times 0.25, which would end up being 1, plus 0.4. So that's going to be 1.4. Well, and here's the other part. We know that all 4 sides are congruent. So if LP is 1.4, then ML has to be 1.4. So the answer to this version is, for the angles, is the same. So we've got MKN. MKN, again, that's a right angle there, so that's 90 degrees. Then we got LMK. LMK is here. Well, all of this was 90, so half of 90 is 45. Then we got MLP. MLP, again, was this angle down here, and all of them are right angles, so it's 90 degrees. Then again, we have Ln. We have that all 4 sides are congruent. So we can set these two opposite sides equal to each other. So 5x plus 0.3 is equal to 4x plus 0.8. 5x minus 4x is x, and then when we subtract 0.3 from 0.8, we get 0.5. Here again, we're going to plug this back in, so 4 times 0.5 is 2, plus 0.8 is 2.8. So this is 2.8. Whoops, sorry. I skipped down to the next one, so we're down here. 2.8. And remember, all 4 sides are congruent, so ML has to be 2.8 as well. Now on this one, LK was 2, which means that KN is 2. And to find Ln, we would do 2 plus 2, which is 4. Okay, now the last 2 questions of our first version says, if a quadrilateral is a square, it is always a rectangle. That is a true statement because a square is a rectangle. And then the next one is, if a quadrilateral is a rhombus, it is also a square. That is false. A square is always a rhombus, but a rhombus is not always a square. Here's our last 2 questions for our other version. So this one says, if a quadrilateral is a rectangle, it is also a square. This is false, because just because it's a rectangle doesn't mean for sure it's a square. If a quadrilateral is a square, it is always a rhombus. That is a true statement, because the definition of a rhombus is it has 4 congruent sides, and obviously a square has 4 congruent sides.